All right, kiddos. Happy snowy morning. Time to talk again, once again, about the nervous system. And last time we finished up talking about what was it? We were talking about neurotransmitters and synapses and all that kind of stuff. And now we're going to talk about the spinal cord. And after we do the spinal cord, we are going to start talking about the brain and then the higher functions of the brain. Those are sort of like, couple of weeks of work that we're looking at with what I just described. All right, so last time we were talking about how memory has this really unusual structure to it, and it's a pathway through the brain, and we had called that a memory trace. And we had said, once you get that memory trace in your brain, you can hang on to it pretty much for life, or that's the standard thing, is to hang on to it for life. And then we had said that it can change, though, and we called that what? We called that the memory plasticity. And that we had said that's why eyewitness testimonies sometimes are wrong. And I know this, being an old guy, I know that when I share memories with some of my family members, my memory and their memory of the exact same event aren't always the same. So one or both of us has it wrong, And what form of memory would that be? That would be long-term memory, declarative long-term memory. And we had said, like every time in the morning I go to tie my shoes, I don't think, oh yeah, how do I do that? No, my fingers do the walking. They do it. And that is a procedural memory. And both of those are long-term memory. And we had said we have short-term memory, which is sometimes you'll be told something and then an hour later you're like, darn it, I can't remember what was that phone number, And that's a case of where your short-term memory didn't get locked away into long-term memory. And then we had said we even have something shorter than that, which is your immediate memory, and it's memory of something inconsequential that just happened. And your mind just says, well, I don't need to remember what it was like the last step or 2 steps ago when I'm walking along if nothing happened. But if something had happened, you could have stored it away as a short-term memory and then possibly as long-term memory. Okay, so that brings us up to the spinal cords. And when we look at the function of the spinal cord, it is conduction, locomotion, and reflexes. Okay, so let's take those one at a time. Conduction. What did we say? We're talking about the spinal cord, and where is it located? It is located between spinal nerves and your brain. So it is going to either be conducting an impulse up to your brain or a motor impulse out from your brain. So its job is to be a pathway, and that's what we're talking about with conduction. Now, speaking of walking, I was just mentioning a minute ago, I said, I might not remember something that happened as I was walking along if it was inconsequential. Now, it ends up, people will say, you hear the term, they can't chew gum and walk at the same time. Well, they probably can. The reason you can walk along and have a conversation is you're not having to think, but your left foot in front of your right foot, you don't have to think about that, right? You just walk along. And the reason that you're able to do that is something called the central pattern generator. So it is resident in your spinal cord. Your brain says, you take care of that, spinal cord. So walking, this repeated process of walking along, frees your brain up to do other things. So locomotion is in residence within your spinal cord. Now, we have one other major function, a third function of the spinal cord, and that involves a reflex. Now, what a reflex is a rapid stereotyped response to a stimuli that doesn't involve your brain. We have what we call a reflex arc. And in the very simplest kind of reflex arc, and it happens to be the one that when the doctor taps your knee and you kick, the patellar reflex, it only involves two nerves. And what it is you have a stretch receptor in the patellar tendon there, and when you tap it with a hammer, what your spine thinks is, so when that tendon stretches, that normally would be when your knee bends, right? So when it's straight, the tendon is short, and then it gets stretched out as your knee bends, right? So when you tap that tendon, it's as if your knee has all of a sudden bent. And so you have this patellar reflex, which says what? Kick it forwards. You don't want to fall down. And that's the whole point of it. In that particular kind of a reflex, there's only two neurons. There's a sensory neuron into the spinal cord and a motor impulse out to your quadriceps, which say, pull your foot forwards, kick your leg forwards. And the whole point of a reflex is to prevent you from having injury. You don't have to think, oh, I'm getting ready to fall. Well, you're already on the ground before you figure that out, right? So a reflex is a quick, stereotyped response to a stimuli. And so in other cases involving, in other cases there is another nerve involved, what we call an interneuron. So in some cases, there are 3 nerves in a reflex. In others, there's only 2. So it's a stereotyped response to a stimuli. Okay, so where does your spine begin? So we have this gross anatomy slide. It's kind of gross, I agree. There it is. We have that slide, and we had said, where does it begin? If you think of your skull, the foramen magnum, the big hole, that's where your spinal cord begins. And interestingly, where does it end? L1. So think. When I say L1, I'm saying lumbar vertebrae 1. And you probably are sitting there thinking, well, wait a minute. My vertebral column is a lot longer than that. And you were right. And it ends up, your spinal cord doesn't grow as much or as rapidly, as much as your vertebral column. So the spinal cord itself ends about L1 or L2. And then, so we have that weirdness of, so it's from the foramen magnum down to about L1 or L2. And then we had said we have different portions of the spine. We have the different enlargements. We have a cervical enlargement, that's in your neck, and it gives rise to, so extending out, I should mention, extending out from the spinal cord, we have spinal nerves. And those spinal nerves come out of the vertebral column in those openings that are created when you stack the vertebrae, intervertebral foramina. So the holes that are created by stacking one vertebrae on top of another are what we call intervertebral foramina, as opposed to the vertebral foramen, which is down the middle. But the little openings to the side are the intervertebral foramina, and you have spinal nerves that come out from there. So these spinal nerves, we have an enlargement, or we have enlargements of the spinal cord, a cervical enlargement, and it gives rise to a network, two networks actually, of spinal nerves that are kind of interconnected. They look like a net, and we call that the cervical plexus and the brachial plexus. And these plexus that are coming out there are going to your arms, your neck, your chest, and your arms. And then we have another enlargement down at the bottom, the lumbar plexus. And what did we say that? Then if you think about that, that's the bottom of the spinal cord. It's giving rise to the spinal nerves that are going out to your legs. So we have that kind of arrangement. In the middle, okay, so as a result of that, so if we said we have 31 pair of spinal nerves that are coming out of the vertebral column, and when you look at that vertebral column, all the way down into the sacral region, we have spinal nerves emerging. So that means that the spinal nerves come out of the bottom of the spinal cord, spit it out. They come out of the bottom of the spinal cord, L1, and they extend down the vertebral foramen and out through the intervertebral foramen in those lower portions of the vertebral column. And so as a result of that, we have something we call Cauda equina. Now those are two Latin words. Cauda means tail. Equina means horse. And the reason they call it that is because it looks like a horse's tail. And so this bunch of spinal nerves that extend down through that lower portion of your vertebral column, these are what we call the Cauda equina. One final point before I move on and come back with another video in a minute is you have something that so if we have this spinal cord that doesn't extend all the way down the vertebral foramen, you need something at the bottom to keep it, from pushing up, riding up, so to speak, inside of there. And so we have something called the terminal filum, which is a fiber that extends out the very bottom point of the spinal cord and keeps that spinal cord stretched out down through the vertebral column. Okay. I'm going to stop right there. We'll be right back.